Hi, this is Kalpana. Now I am going to do presentation on power allocation and channel estimation using non-orthogonal multiple access in 5G. These are the content. We know that there is a massive growth in the number of devices and we are demanding for high data rate, low latency and highly reliable communication system. So this will be provided under 5G, that is 5th generation cellular networks have promised to satisfy these conditions for future application and services. The 5G technologies include MIMO, OFDMA, NOMA and then D2D communications. Here in this project, I implemented NOMA, that is non-orthogonal multiple access. It is one of the advanced technology which provides high system capacity, low latency, massive connectivity for several users. Here, the existing system is OMA, that is orthogonal multiple access. There is a only limited number of user, but for in case of NOMA, there is several user with using same time and resource. Here in this diagram, I consider one base station with two users, that is user 1 with the higher channel gain and user 2 with the lower channel gain. Obviously, user 1 is a strong user and user 2 is a weak user. Here, strong user subtract signal of a weak user through SIC, that is successive interference cancellation, and obviously it decodes its own signal. And for the weak user, it considers a signal of the strong user as a noise and detect its own signal directly. NOMA schemes can be classified into two major types, that is power domain multiplexing and then code domain multiplexing. The name itself indicates that in power domain multiplexing, the users are allocated with different power coefficient according to their channel condition. Here in this project, I implemented power allocation, so I used power domain multiplexing, and another one is code domain multiplexing. Here, different codes have been multiplied over the same frequency resources such as MUSA, SCME and then LDS. These are the some of the literature survey I used for this project. In this first paper, Shannon formula and high model used for the channel estimation and power allocation. Similarly, in the second paper, improved adaptive codebook channel estimation have been used for the algorithm for OFDMA wave system. And these are some other literature surveys. The objective of this project is to develop a scheme for power allocation utilizing the channel estimation information for power domain NOMA. Here initially channel estimation is done, that is the channel is analyzed using MMSE and SVD to know the mean square error. Here these two systems are compared and power allocation is done for near user and then weak user using NOMA. That is maximizing the average effective SNR of the strong user while maintaining the certain average effective SNR of the weak user. Initially input is given and after that serial to parallel converter takes place. Here the modulation implemented is 1. Then IFFT takes place for the time domain. Then cyclic prefix symbols are added to reduce the intersymbol interference. And again parallel to serial converter takes place. Then beamforming, that is the major advantage in 5G is beamforming, and after that fading channel have been implemented, that is here I considered a railing channel. So while going to the channel there will be a power drain, so to optimize this power allocation scheme have been implemented. So and what are the operation takes place in transmitter side, the inversion operation takes place in the receiver side. The software I used is MATLAB R18A, and obviously there is an application that is IoT and MIMO NOMA. These are the simulation results I have been implemented. Here I compared SVD and then MMSE to measure the mean square error. By using this graph, we know that SVD provided performance is good when compared to MMSE. This graph shows the BER performance, that is case 1, case 2 and then case 3. The case 1 says that the power allocation, that is for user 1 and user 2, same level of resource have been given. Next in case 2, the user 1 is provided with 0.75 and for user 2 there is 0.25. Here the efficiency is achieved better. And in case 3, the user 1 is provided with 0.25 and for user 2 it is 0.75. Here also it is degraded. This BER graph performance shows that a fair dynamic power allocate scheme, that is principle used to satisfy the BER requirement of the far user and then allocate the remaining power to the near user. Significant improvement in performance can be achieved by dynamic power allocation. So So finally, this project is focused on channel estimation and power allocation for NOMA based 5G networks. The simulations are carried out to analyze the performance of channel estimation techniques and power allocation schemes. Further, the BER versus transmit power analysis had shown for near user and then far user using dynamic power allocation scheme. This will improve the overall system performance.